This is a video on the error bound for an alternating series. The question states, determine the number of terms required to approximate the following series with an error of less than 0.001. And we have the summation from n equals 1 to infinity of 4 times negative 1 to the n minus 1 over 2n minus 1. So the error-bound formula for an alternating series says that if we add up the first n terms instead of all infinity of the terms, if we add up the first n terms of this alternating series, then the error in adding these up compared to taking the whole series will always be less than the absolute value of the n plus first term. So let's look at the absolute value of the n plus first term. What that means is I take an absolute value, so I get rid of the negative 1 to the n minus 1, and where I see this n, I put in an n plus 1. So we can say the absolute value of a sub n plus 1 is equal to 4 over 2 times n plus 1 minus 1. Now, the error-bound theorem says that this will always be greater than the error. So if we set this to be less than 0.001, then that will give us the n that we need to use to calculate the first n terms to get a small enough error. So the rest is just algebra. I'm going to multiply the 2 through and combine like terms. And I get that 4 over 2n plus 1 is less than 0.001. And now let's do a little algebra trick. I'm going to take the reciprocal of both sides. So when you take a reciprocal of both sides, the inequality switches. And also, the reciprocal of 0.001, this is 1/1000th, and its reciprocal is 1,000. So I get 2n plus 1 over 4 is greater than 1,000. And now let's continue on the algebra, multiply by 4, and I get 2n plus 1 is greater than 4,000. And then just subtract 1 and divide by 2, and I get that n needs to be greater than 1,999.5. So let's let n be 2,000, and then we'll be ensured that our error is smaller than 0.001. So I can conclude that adding up the first 2,000 terms of this series will approximate its sum with an error of less than 0.001. And just of interest, this series, you may not recognize this series, but it's pretty special. It's actually one of the representations of the number pi. So I went in and I calculated using a calculator, and I added up the first 2,000 terms, and what I got was 3.1411. That was, again, taking n equals 1 to 2,000 instead of n equals 1 to infinity. Note, by the way, whether you remember or not, pi up to 4 decimal places is 3.1416. So this approximation is very, very close to pi. And I'm done with the problem.